We continue Unit 3 inverses with Flap 5 interpretable composite functions. Composition of functions is the process of putting one function inside another. The notation for composition of functions is f of g of x. We read it f of g of x. You are replacing every x in the outside function, in this case f, with the entire inside function, in this case g. So given f of x is equal to 3x plus 2, g of x is equal to 2x squared minus 2, and h of x is equal to 1/2 x plus 1, we need to find the following: f of g of x. To begin, we are looking at f of x. Wherever there is an x in f, we will be putting g in its place, leaving a space where x is supposed to be, and I will replace x with what g of x is. So g of x is going in the space where x is. G of x is 2x squared minus 2. Now I just do simple algebraic techniques, simplifying, following the order of operations to find out what f of g of x is. So using PEMDAS, we distribute 3 throughout both terms. 3 times 2 is 6x squared. 3 times negative 2 is negative 6, and then plus 2. Combining like terms, and we get 6x squared negative 4. So f of g of x is equal to 6x squared minus 4. First, we substitute g of x into x in the function f. Then we simplify and get our answer. Now let's look at g of f of x. We will use the same principle as 4, except now it is in reverse order. And everywhere I see an x in g, I will substitute f. So write down the equation for g of x, leaving a blank where x is, and in that blank we will be putting f of x. F of x is 3x plus 2. Now we solve. Now 3x plus 2 squared is the same thing as 3x plus 2 times 3x plus 2. Now we simplify by multiplying inside the parentheses first, and this is binomials, so we will be multiplying the two binomials together and get 9x squared plus 12x plus 4 minus 2. Then multiply through by 2 to every term. We have 18x squared plus 24x plus 8 and minus 2. Now let's combine like terms to get 18x squared plus 24x plus 6. Let's look at another example. G of h of x. So now, everywhere I have an x in g, I will substitute an h. G of x, again, is 2x squared minus 2. But everywhere I have an x in g, I want to substitute h. Write your equation, leave a blank spot where x is located, and now we're going to plug in h of x. And h of x is 1/2 x plus 1. So we're substituting h of x in for x. Now we just need to solve this problem. Now multiply through by 2, and we get 1/2 x squared plus 2x plus 2 minus 2. Now just combine like terms, and our answer is 1/2 x squared plus 2x Let's look at another example. h of f of x. Now we're going to write h down, and wherever there's an x in h, we will replace it with f. So h of x is 1/2 times x plus 1, and f of x is 3x plus 2. Now we simplify. So half of 3 is 3 over 2. Half of 2 is 1. And there's still a plus 1 out here. So I have 3/2 x plus 2. The next composite function is h of g of x. So we will start with h, and everywhere I have an x in h, I'm going to leave a blank and replace it with g of x. G of x is 2x squared minus 2. And now I simplify. So half of 2x squared is just x squared. Half of negative 2 is just negative 1. I still have plus 1. And when I combine negative 1 and plus 1, my answer is just x squared. This concludes day 4 of our Unit 3 Foldable Inverses. Thank you.